Okay, so today we are going to be talking about piecewise functions. Okay, so our first piecewise function question is going to be over graphing piecewise functions. So the first function is h of x equals 2 if x is less than or equal to 1, and x if x is greater than 1. So we'll start by looking at our domain. Our domain is where x is at 1, so that means that our two pieces to our function are going to be cut along this line. So we'll start with the first function. It's a constant function. To graph each piece, we need to create a table. For the first function, since it's a constant, that means it doesn't matter what I plug in for x, the y value is always going to be equal to 2. The first number that we choose for our x values will come from the domain. So since the domain is x is less than or equal to 1, I'm going to put a 1 as my first x value. Our second point just needs to fit the domain. So x is less than or equal to 1. I need to pick a number that's less than or equal to 1. So for my second number, I am going to choose 0. And then normally I would go ahead and take my x values and plug them in to figure out what my y values are. But again, this is a constant function. So since it's a constant function, all y values are just 2. So I'm going to go ahead and write in 2 for my y values. And this should be a horizontal line. So I'm going to plot these points. The first point is special in our table. We have to determine if it's going to be open or closed. And we can figure that out by looking at whatever the inequality is. So it's a less than or equal to. Anytime we have that equal to symbol, it's going to be a closed point. So I'm going to put a closed point at 1, 2. Oops. Try that again. Okay, so there's my point. Actually, no, that's better. Okay, so I put my point at 1, 2, and my other point will be at 0, 2. And then after I have those points plotted, I draw in the line, starting from the first point through the second point, all the way to the end of the graph. Okay, and now we're going to move on to the second piece of my function, which is x if x is greater than 1. So when I create my table for this one, I'm also going to start with the first x value as 1. I get that from looking at my domain. The next x value comes from my domain again. This time I just need to choose a number that is greater than 1. So I'm going to choose 2. And then I'm going to take those numbers and plug them into my function. So this one is actually really easy. If I take 1 and plug it in, if I plug 1 in for x, x is the function, so it's just going to be a 1. If I plug 2 in, it's just going to be 2. So now I can go ahead and plot my points. So again, looking at my first point, 1, 1, I have to look to see if it's going to be open or closed by looking at my inequality. This time it doesn't have the equal sign under it, it's just a greater than, so this is going to be an open point. So I will put an open point at 1, 1. And then I'm going to put my next point 2 at 2, 2. Should be right here. And then drawing my line from the first point through the second point all the way to the end of my graph. And normally we would use a straight edge for this to make sure that our line ends up going through the correct points. Okay, and that is it. That's how we graph our piecewise function. So a second example of doing the same thing we just did in the first one. This is number 1 from the homework assignment. We have f of x equals negative x plus 1 if x is less than or equal to 0, and negative 4x over 3 minus 4 if x is greater than 0. So we're going to start by creating two tables again, one for each piece of the function. Okay, the first value comes from our domain, whatever the domain is. So since it's x is less than or equal to 0, that's the first point we're going to use. The second point needs to fit our domain. So if x is less than or equal to 0, I'm just choosing a number that's less than or equal to 0. So I am going to pick -1. And then I take those numbers and I plug them in. So if I plug 0 in, -0 is 0, plus 1 is 1. If I take -1 and I plug this in, this is where some people make a mistake. That negative symbol, it's actually negative x. So when I plug -1 in for x, I need to put it in parentheses. This first negative symbol comes from the symbol that's in the equation here, -x. That's where this is going to come from. And then the -1, that negative symbol, is where I get the second one. Plus 1. So negative and a negative, this is going to cancel out here. So this is the same thing as 1 plus 1, which gives us 2. And then we plot our points. So first point, I need to check to see if it's going to be open or closed by looking at my inequality. The inequality is a closed, it's less than or equal to, so that means it's going to be a closed point. So I am plotting a closed point at 0, 1. And then my second point, it will be at -1, 2. Oops. And then I need to draw a line from the first point through the second point and continuing until I get to the end of the graph. And you should be using a straight edge for this, otherwise it doesn't come out too straight. See how mine looks a little bit curved. And then our second function, -4x over 3 minus 4. So the first number we use, again, comes from our domain. X is greater than 0. So 0 will be my first x value. Now the second x value for this one, what I would recommend is take a look at the fraction. We need to take or choose an x, that when we plug in x, it's going to give us a whole number. Otherwise, we're going to deal with fractions and decimals and things like that, and that's much harder to graph. We want to graph a whole number. So I need to think of an x that I can multiply by 4, divide by 3, and still get a whole number. For example, if I plugged, let's see, x is greater than 0. If I plugged a 1 in here, I would get -4 over 3. And when I subtract the 4, I would still end up with a fraction. So I want something other than that, something that's greater than 0, that's going to give me a whole number. So for example, I would probably choose, and if you need to, you can guess and check. So I tried 1. If I tried 2, 4 times 2 is 8, divided by 3 would still give me a fraction. If I plugged in 3, 4 times 3 is 12, divided by 3 would give me a whole number. So that's what we're going to use. If you wanted to, you could use 1 or 2 or something like that that gives you a fraction, but it's more difficult to graph. So I am going to use 3 because that is a number that is greater than 0, and when I plug it in, I get -4 times 3 over 3 minus 4. So 3 times 4 is going to make that 12. And remember, this is negative. So -12 divided by 3 gives us -4. And then minus 4 is going to give us -8. Okay. And then I need to also plug in the 0. And if I plug 0 in here, 4 times 0 divided by 3 is all 0. Minus 4 gives us -4. So anytime we have a fraction like this, just be careful what you're plugging in. Otherwise, you might end up having something that's going to be difficult to graph. And then we would go ahead and plot our points. So the first point, 0, -4, this is going to be an open point. And I know that from looking at my domain. It's a greater than symbol. It doesn't have the equal sign under it. So the first point that I plot is going to be open. So 0, -4. Plot an open point there. And then 3, -8. It's going to be right here. And our second point is always closed. And then we are drawing a line from our first point through the second point to the end of the graph. And that is our piecewise function. Okay, next we're going to look at an example of writing the function when we're given the graph. So this isn't the same problem, but it's similar to the last problem in our homework. So we have 3 different pieces here. So what I'm going to do is I'm going to look at where the domains are going to be for my function. And it looks like I have 3 different pieces, so I'm going to have 3 domains. One that will be along -1. The others will be along +1. So I am going to say, I'm going to call this function f of x. And there are going to be 3 pieces, so I want to make my function big here. I'm going to fill in the domain first, just because the domain is the easier part. The second part of this is just writing the equation, and that isn't very difficult for us. We just need to find the y-intercept and the slope. So the first part we're going to do is the domain. So for the blue piece, it looks like we start at -1, and we are going to the left. So when we go to the left of -1, all of these x values are less than -1. So the domain for my first piece, that blue piece, is going to be x is less than -1. Okay, for my second piece, the red piece, this is going to be an interval, so my x values, my domain, are actually between 2 numbers. They're between -1 and +1. So I need to write my x between -1 and +1. Since these points are filled in here, that means that one of the pieces has a less than or a greater than symbol, no equal sign. And then the other piece where they connect will have an equal sign under the inequality. So since I chose this, I chose greater or less than, no equal sign for this first piece. This second piece, since this point is filled in, I'm going to have to make that a less than or equal symbol. And all that means is that when I graph this, my first piece of my function will have an open point. The second piece of the function, the red piece, has a closed point, which ends up making this closed. We can't put less than or equal to, less than or equal to for both of these. Otherwise, it would make this, we wouldn't be able to call it a function, because we would have 2 points where our x values are the same. So what we're going to do then, I'm going to go ahead and make this a less than or equal to piece also. So the last piece of this is the green. So for the green piece, this starts at +1, and it's all the numbers to the right of +1. So that means that it's going to be x is greater than 1. And I don't include the equal sign under here because I've already included that for one of my domains. Okay, I've already filled in this point by saying that this piece, that x is less than or equal to 1, that point would be filled in. So when I do this for the green piece is going to have to be an open point. We can't have 2 closed points at the same space. So those are my 3 domains. The last thing I would need to do then is write the equations of the lines. So for the blue point, or the blue piece, I need to look what my y-intercept is and what my slope is. So to find the slope, I just look at 2 points on my line. So I'm going to pick this one, and I'm going to pick this one. So I need to go up 1 over 1, up 1 over 1, up 1 over 1. So it looks like the slope of this line, by finding my rise over my run, is 1 over 1. So the slope of this line is 1, and the y-intercept, for this line, it doesn't actually go through the y-axis. To find the y-intercept, I'm going to take the line, and I'm going to use my slope to continue it through till I hit the y-axis. And I do. I hit it in the next point. It looks like it hits it at +2. So my y-intercept is +2. My slope is +1. So the equation for this line is x plus 2. We put this in y equals mx plus b form. So this is what we filled in. We took the 1 and we plugged it in for m. We took the 2 and we plugged it in for the y-intercept. And when I plug 1 in for m here, if I plug that in, 1 times x is still x, so that's how I got my last answer, x. And then I took the 2, I plugged that in, I got plus 2. So for the next one, the red piece, this is a constant function, and it's a constant function that goes through positive 1. So all I need to write for this one is 1. Anytime we have a horizontal line, the equation for that line is wherever it hits the y-axis, y equals that number. So all I need to do is plug that number in. And then the last piece, the green piece, checking my slope. So I'm going to choose this point and this point, 2 easy points to choose from my line. And it looks like I need to go up 1, 2, 3, and over 1. So the slope is 3 over 1, which is equal to 3. The y-intercept for this one then, I need to go in the opposite direction. So instead of going up 3 and over 1, I'm going to go down 3 and over 1. This would be the next point of that line. And it hits the y-axis, so I can go ahead and stop there. Another way to do this is if you had a straight edge, you could lean it up against the line, and you could just look at where the line would hit your y-axis instead of using the slope. And so here, the line would hit it at -2. So my y-intercept for this one is -2. And then I would just plug those into that equation. So 3x minus 2. Plugging the 3 in for m, plugging -2 in for b. So that's how we get that. And that's the end of the function. I've written it all now. So you write each individual piece, and that's it. Domains first, equations second. Okay, so another example of what this would look like trying to write the equations. So for this one, I only have 2 pieces. So I am going to say f of x equals... Okay, so looking at my function, it looks like they are going to split up at -2. So where my 2 pieces are. So my function, my domains for them will be at -2. The first piece of my function, it looks like it's going to the left of where that center is. So since it's going to the left, that means that my x's are less than -2. And this is a point that is filled in, so it's actually less than or equal to. So for the first one, I'm going to say x is less than or equal to -2. The second piece are all the numbers that are to the right of -2. So since we're going this way, that means that it's all the x's that are greater than -2. And this point is an open point. So when I write the domain, it's just going to be x is greater than -2. No equal sign because it's open. Alright, and then I need to write the equation. So the first one should be pretty easy. It's a constant function. We can tell because it's horizontal. So all we need to do is look where it would hit the y-axis, and it would hit it at +1. So the equation for the first one, I'm just going to write +1. Anytime we have a horizontal line like this, that's a constant function. And the equation for that is just y equals wherever it hits the y-axis. The second piece of my function is a line that is going up to the right, so I know my slope should be positive. I'm going up 1 over 1, up 1 over 1, up 1 over 1. To find the slope, we just choose at least 2 points on the line, and we just check our rise over our run. How far up or down we need to go, how far to the right we need to go. So for this one, I'm going up 1 over 1, up 1 over 1 each time. That means my slope is 1 over 1, which is just 1. The y-intercept, this actually does cross the y-axis. Crosses it at 0. So the y-intercept for this one is 0. And remember, we're plugging that into y equals mx plus b. So I take my m and I plug it in. When I plug 1 in for that, 1 times x. Plugging 0 in for b. And when I simplify this equation, 1 times x gives me x. And then when I take x plus 0, I still just have x. So the equation for that second line is going to be x. Okay, so just to recap, if we have a constant function, the equation for that line is going to be wherever it crosses the y-axis, just that number and that number only. The equation for any other line that's going up from left or right, or if it were going down from left or right, we need to find the y-intercept and we need to find the slope. And after we have those two numbers, we plug it in. And then we simplify if it's possible. Most of the time, if it's like a 1 or a 0, it can be simplified. Anything else probably won't be. After we have it simplified, we just write our functions here, make sure the domains are written here. And the only reason that I write the domains first is because it's usually easy to point out the domains. Okay, so hopefully this has helped you kind of get an idea of piecewise functions, a little bit better idea of piecewise functions. If you would like more of these videos, please like them on Edmodo so I know that people are listening and watching. Thank you.